Hi everyone, Algebra 2 2.3, Extrema and End Behavior. We'll cover those topics together. End behavior, relative maximum, relative minimum, turning points, extrema. Describe the end behavior of each linear function. Okay, end behavior means as you go to the left, left, left on your graph, what happened to the y value? Y value, what's happening to y value as you go to the left? Its y value is going down. Y value is decreasing. Okay? As you approach the left, y decreases. As you go to the right, what happened to the y value? What happened to the y value? Y increases. Okay? So, you have to be familiar with this notation. As you go to the left, we said y goes down. As we go to the right, y value goes up. That's what we said on this graph, right? And that's how you say, fancy way, as x approaches to mistake. So I put that here. So that should go here. Left down is this one. As you go to the left, y goes down. As you go to the right, y goes up. Up. So as you go to the right, fancy way of saying that is in x-axis, going to the right means going toward infinity. Going to the left on x-axis means you go to the minus infinity. So as you go to the right, that means as x approaches to infinity, that's the same meaning. Y goes up. Well, y-axis is this. So going up is approaching positive infinity. Y goes down, that's approaching to minus infinity on y-axis. So a fancy way of saying y goes up, that's the same as y, f of x is y. F of x approaches to positive infinity. Okay, in algebra 2, this is how you say it. As you go to the left, y goes down. As you go to the left, fancy way of saying that is as x approaches to minus infinity. As x approaches to minus infinity, that's same as going to the left. What happened to the y? Y goes down. F of x is y. Y goes to minus infinity. That's what I mean by going down. Okay? Okay, one thing you want to be careful here, this writing won't change. Whenever I ask you end behavior, you will write this as it is every single time. Only change is this. What I'm gonna write here. What I'm gonna write here. Okay? So that's the answer. Describe the end behavior of each linear function. Okay, so this is straight line. So as you go to the left, what's y value approaching to? Y value is minus 1.5. It doesn't change. As you go to the right, what happened to the y? Y value doesn't change, which is minus 1.5. So how do you write that? Here. So make sure you know you can write like this. I told you this statement does not change. You always write like this. As x approaches go to the right, as x approaches to positive infinity, what happened to the y? Minus 1.5. As x approaches to minus infinity, that's same as you go to the left, what happened to the y? Minus 1.5. Okay? Right hand limit, the right hand end behavior, left hand behavior, both of them is minus 1.5. And the behavior, same thing. As you go to the left, what happened to the y? Going down, going down. So do you remember how to say that? As you go to the left, x opposed to minus infinity, y goes down. Going down is minus infinity. As you go to the right, what happened to the y? Y goes up. As you go to the right, this is how you go to the right. What happened to the y? Positive infinity. That's how you answer. Please pause the video, you try this. Okay, as you can see, left hand goes down, right hand goes down. So both of them goes to the minus infinity. As you go to the right, y goes down. As you go to the left, y goes down. Make sure you can write this as it is. Okay, that's how you should be able to answer the question. That's fine. Okay, the table and graph below are the function with extrema. Estimate the zeros. Zero means x-intercept. Then estimate the coordinates at which relative maxima and minima occurs. So pay attention to y value. Y value. Y value is 0. That's where the zeros are. Y value 0 means the value is hitting x-axis. So where are the zeros? Right here. Y value 0. So zeros are minus 2. Y value 0, 0. So we got two zeros. Zeros minus 2, comma 0. Where y value becomes 0. Okay? X value becomes x-intercept. Then estimate the coordinate relative maxima, relative minima. Okay, you're looking at y value. 9 to 0, decreased. 0 through minus 1, decreased. Minus 1 to 0, increased. 0 through minus 3, decreased. Minus 3 to minus 16, decreased. Minus 16, minus 45, decreased. Okay, so y value decrease means it keeps going down. Increase means it turns around, it increases and decreases. So you should know, keep decreasing and increasing here. So you should know 0, 0 is somewhere you should have a maximum, relative maximum. Decrease, and you start increasing right here, you should know minus 1, minus 1 should be somewhere minimum is. Okay? It's easier if you plot them on a graph. Okay? So if you plot those points on a piece of paper like that, it's somewhat like this. So decreasing, all of a sudden increasing. So when they start turning decreasing to increasing, that's when you have minimum. Increasing to decreasing, when that turns around from increasing, decreasing, that's when you have a maximum. So decreasing to increasing, right here, most likely we will have relative minimum. So relative minimum at near x equal to minus 1, right here. Increasing to decreasing is around 0, 0, so the relative maximum near 0, x equal to 0. Which is a lot clearer if you, once you plot the coordinates. Okay, the table and the graph represent the balance in Friedrich's savings account over a year. Use the table and the graph to estimate extrema for this function. Then explain the extrema in context. Okay, very simple. Even the graph is provided. Relative extrema, relative maxima is right here, right here. Okay? So relative maxima at x equal to 5. This is a 5, x equal to 5, x equal to 8. Relative minima at right here and right here. as 6 and 9. I actually might consider this as a relative minima as well. That's relative minima too. So I'll include a 1. Relative minima at 1. 6, 9, 1. I'll take a 3 for relative minima. So as long as they are minimum locally, I call that as a relative minima. Okay? I think that's it. Yeah, so given the graph, finding relative maxima, relative minima shouldn't be that big deal. That's all for this lesson.